How do you find the sum of finite geometric series, meaning the fixed number of sequence, sum of the fixed number of sequence? Here's the formula. You do the first term times 1 minus ratio to the nth power divided by 1 minus r. So what kind of sequence is this? What are we doing each time? We double it, so it is geometric because it has a common ratio of 2. What kind of function would model this sequence? Let's look at the explicit equation of geometric sequence. It is an equals to the first term 3 times the ratio 2 to the n minus 1. That's the explicit equation for geometry. What type of function would that be? It is exponential, right? You multiply by 2 each time. It will look something like this. 3, 6, right? It grows exponentially, so it's exponential. Graph. And now, how do you find the series? Let's plug into this formula. Find the sum of the series from 3 to 192. And what's the pattern? Times 2. So it is geometric. And how many terms? How many sequences are we adding? 1, 2, 3, 4, 5, 6, 7. So n is 7. So how do you find the series of 7 terms? It equals to the first term, a1, 3 times 1 minus, what's the ratio? 2. What's the n? 7. Divided by 1 minus 2. So it's finish one step at a time. Complete one step at a time. So it's 3 times, what's 1 minus 2 to the 7th? 1 minus 2 to the 7th. Negative 127. Negative 127. And you divide it by what? What's 1 minus 2? Negative 1. So I get 3 times 127, which equals to 381, but we divide by negative, so it becomes positive 381. You can double check your answer by adding these 7 numbers. All right? This was an easy one. Why? They gave you all these numbers, so you could just literally just plug into the calculator. But what if you have a question like this? So how do you find the sum of the geometric series? So what are we multiplying each time? Times negative 1/2, which is same thing as negative 0.5. Sometimes it's easier to use the decimal to plug into this formula. And how many terms are we adding? 12. So we are finding the series of first 12 terms. So it equals to the first term, which is 4 times 1 minus, what's the ratio? Negative 0.5. Or 1/2, raise it to the 12th power, and 1 minus half. Since I'm going to plug into the calculator, I'm going to just write 0.5. Okay, so what do I get? It is 4 times negative 0.5. You're right, it's 1 minus negative 0.5 because our ratio is negative. So let me just do the bottom first. What's 1 minus negative 0.5? It's 1 plus 0.5, which is 1.5. That was easy. What about this one on top? I think I'm going to just plug into the calculator. So it is 1 minus parentheses negative 0.5 raise it to the 12th power. Math, enter, enter. I get, no, that's not right. Oh, maybe it is right. 40 Yeah, I think it is right. 40, 95 divided by 40, 96, right? So then what do? You divide it by 1.5 for this, and what do we do? And then you multiply by 4, and you hit math, enter, enter. I get 1365 divided by 512, which is about 2.666. It gets, why? How can this be so small? We even started from 4. But look at this. We subtract it, it becomes negative, positive, it alternates the terms. So it almost became 2 and then added 1. But as the n increases, what type of number does it become? It becomes very small, right? So that's how it approaches to 2.666 when there are 12 terms that we are adding. Next time, what we're going to do is what will happen if we add infinitely many terms. It could either converge or diverge.